What does grain structure tell us in metallography? Imagine peering into a tiny universe inside a metal piece. The way those tiny crystals are arranged can reveal a lot about how the metal was made and how it might fail. When metallographers look at grain structures under microscopes, they see the size, shape, and orientation of the crystals that make up the metal or alloy. These grains form as the metal cools from a liquid state, and their characteristics tell us about the processing history. For example, smaller, evenly shaped grains usually mean the metal is stronger and tougher. Larger grains might suggest the metal was cooled too quickly or has undergone some heat treatment that changed its properties. The boundaries between these grains, called grain boundaries, act like barriers that slow down the movement of dislocations, which are tiny defects that cause deformation. So, the grain structure influences how the metal responds to stress and strain. Looking at the grain structure helps us understand what kind of process the metal went through. If the grains are uniform and equiaxed, it often indicates controlled heat treatment or forging. If the grains are elongated or distorted, it might mean the metal was rolled or subjected to directional solidification. This information is essential in failure analysis because it can reveal causes of mechanical failure. For instance, abnormal grain growth can weaken the material, making it more prone to cracking. Microcracks or non-metallic inclusions visible at the grain boundaries can also point to manufacturing issues or improper cooling. Changes in grain size or shape can be signs of overheating or rapid cooling, both of which can compromise the metal's strength. To see these details, metallographers prepare samples by cutting, polishing, and etching the surface to reveal the grain boundaries. They often use optical microscopes or electron microscopes for a closer look. Advanced software can measure the size and distribution of grains, giving precise data that relates to how the metal will behave mechanically. This analysis helps engineers and failure analysts trace back to the root causes of problems, whether it's a material defect or a processing error. In short, the grain structure is like a storybook of the metal's life. It tells us how it was made, how it has been used, and why it might have failed. Understanding these tiny crystals helps us improve materials, prevent future failures, and make safer, more reliable products.